Hello everyone. Now today we will see the bending moment of a beam. So already we have seen what is the beam. Beam is one in which length is greater than its other dimensions. Other dimensions may be the length and breadth, or we can say height and breadth. If this is a length and other dimension, this is a two-dimension diagram, so that I cannot able to show you the breadth. So this is the height. Okay, so this is called as the beam, right? And now when we bend this, it takes it's the shape. Now a bending moment we have to find out of this particular beam. Okay, what is the bending moment? Bending moment means finding, let us say this is some beam or some stick is there. So one end is fixed and to the other end I am giving the force. Okay, where this point is fixed and where this point is free to move, this end is free to move, then what is going to happen? This is going to bend, this is going to rotate. Okay, twist is going to happen. Okay, or torque is going to produce. The bending moment is nothing but this distance, into the force which we are applying is called as bending moment, or torque is producing there. Or even we can take like this. Okay, this is a fixed point, let us say O, and we are applying the force over here, so that this F into R, so this is going to rotate. Okay, so this is going to form a couple. Okay, we call it as the bending moment, right? So this is F into R is the bending moment. In this derivation we are going to find out what is the Fr, that is couple produced, or the bending moment, or we can say the torque which is produced while we bend it. Okay, so now this is the beam, and here we have the neutral surface or neutral axis. What's a neutral axis? The axis which will not change its dimension even after bending it. So here you can observe, so this is before bending and this is after bending. So CD is the neutral axis. Neutral axis means it is not changing its dimension, whereas this AB is the original length of this A dash B dash after bending. Okay, what is happening? What is the difference between AB and A dash B dash? A dash B dash has increased its length. That means it has been elongated. Okay, it is elongated. Now this EF length, it has been contracted or compressed. Okay, the length has been become less. What it means is all the planes, there will be so many planes here. Okay, so for representation purpose, what I have taken is AB1 plane I have taken, and EF1 plane I have taken. Okay, so there will be so many planes. So after bending, all the above this CD, all the planes above this CD are going to elongate, are going to increase their length. So all the planes below the CD are going to contract or compress. So this is the after bending. This is the diagram. So in this case, we are going to find out the bending moment of a beam. Okay, let us start. So now what is the change in the length? Okay, so we have to find out the change in the length. Change in the length, that is equal to, so what is change in the length? That is new length which is produced minus original length. Okay, right? What is the new length which is produced? New length is A dash B dash minus, what is the original length? AB is the original length. Let us say this is equation number 1. Fine. Now what is A dash B dash and what is AB, we have to substitute, right? So okay, I'll consider the same diagram here. I have considered the same diagram of this, Okay, now what we will do is we will extend this line. When I extend, this will be like this. When I extend, it will cut, it is going to cut here. So I'll take this angle as theta. I'll take this angle theta. Okay, and let us take, and it has become the part of a circle now, and this will be the radius of that. Okay, from this and this will be radius, and this distance, this is a small r, right? So this distance, what I am taking, this is the small r and this is the capital R. Okay, according to trigonometry, now what is CD? CD is the arc length. Okay, then can I write that CD as it is r into theta? Okay, we know according to trigonometry, it is if it is like this. Okay, we have this arc and this is the theta, this is r. Okay, so that this r into theta, so this is r into theta is the arc length of that. So this is CD is the arc length, that is r theta. Now what is this a dash b dash? A dash b dash we can easily write it as the radius will become r plus r into theta. Okay, by substituting in this equation, equation 1 will become, okay, equation 1 will be, it is r plus r into theta minus r theta, that we can write in turn r theta plus this r theta minus r theta, so that this equation 1 will be, this 2 will get cancelled and I'll get this small r theta. So what we found now, we found change in the length. So this is the change in the length. Okay, now what is original length? Original length is, this is AB is the original length and A dash B dash is the length after the bending. So this is the change in the length. Once we find the change in the length, we can find out what is strain or longitudinal strain. We can find out. Let us find out the longitudinal strain. Longitudinal strain is equal to, what is the definition? It is change in length divided by original length. Okay, so what is the change in the length? Change in the length is this, that is r theta divided by, what is original length? Original length is AB. AB is the original length, right? So AB is the original length. So AB is equal to CD, so that I can take it as it is AB. Okay, so now what is the original length? Original length is AB. Original length is capital R theta. Okay, so what we got now, it is R divided by R. This is the strain which is produced. Okay, now what is the stress or longitudinal stress? Longitudinal stress is, it is force per unit area. Okay, this is the stress. Now we got two things, longitudinal strain we have with us, longitudinal stress we have with us. Okay, what is the next step we can find out? The Young's modulus. Therefore Young's modulus is equal to, it is stress divided by strain. Okay, that is longitudinal stress divided by longitudinal strain, that is equal to, this is Young's modulus. What is stress? Stress we can substitute it as F divided by A. Strain is small r divided by capital R. Fine. So now what I want, I want R into F. In this derivation, we want R into F. We want this quantity. So this is the couple or bending moment we have to find out. That means let us take everything to the left hand side, and one side we want the r. We can write like this. We can take f to one side and remaining terms one side. We want r into f, that is couple, right? So that now let us multiply r both side. What we will get is, this is rf is equal to ar square y divided by this r. So this is the equation, and this is the bending moment. Okay, so what we found now is, it is bending moment y r ar square. Okay, this is for only one line we have taken, a b c d e f, only we have taken for a b. Okay, this is for one plane. Okay, so we have to extend this to the beam, to how many layers are there, to all the planes we have to extend, so that now we will take the summation of this. Let us take summation. So here Young's modulus is constant and this radius is not going to change. What is going to change is that little thing, that small r is going to change, and the area of that is going to change. Okay, so that this is y divided by r. Now we have to take the summation over a r square. So this will become bending moment for the beam, complete beam, right? So here we can replace this summation of ar square with ig, summation of this with the small ig, where this ig is equal to this ar square, and this is called as, it is geometric moment of inertia. So this is the inertia which is there. So this is the general equation which we have now. Okay, now if the beam can be like this. Okay, so the beam, this is the rectangular beam which has got length, breadth and height, and this is the beam, this is a circular beam. Okay, this has got radius, it is the circular beam. So for bending moment of beam for rectangular beam, okay, for rectangular beam, for this rectangular cross section, where the cross sectional area is a rectangle, for such a kind of a beam, for rectangular beam, okay, bending moment is given as y divided by r. This is directly I am writing bd cube divided by 12. So this is the formula for rectangular beam. And for circular beam, we have this formula where the cross section is circular, pi divided by 4, and this is y rho raised to 4 divided by r. Okay, where rho is radius, where rho is the radius of this beam. Okay, this is the rho. Okay, why they have taken here rho they have taken because not to confuse with this small r, they have taken rho here, and these two I have taken directly, and there will be only one problem on this formula. So in the numerical examples we may get such a kind of a problem. So the derivation is till here only. Okay, the derivation is till here, and in the examination if they ask, you have to answer till here. No need of these two formulae. These two formulae are used to solve the problems.